So the next compromisation is compromising session IDs using client-side attacks. Client-side attacks targets the vulnerability in the client applications that interact with the malicious server or process malicious data. Here, the server can be a malicious one. So, as you can see in this diagram, um, the server is a malicious in this example that is shown in the figure. It when attacker when a victim sends a request, the malicious server will attack. So what are the different compromisations using client-side attacks? The first one is cross-site script attack, commonly known as XSS attack. Attackers insert a malicious JavaScript, VB script, ActiveX, hypertext markup language, HTML, or Flash applet into a vulnerable dynamic page. That page then executes the script on the user's machine and collects personal information of the user, steal cookies, redirect users to unexpected web pages, or executes any malicious code on the user system. So next is cross-site request forgery attack, CSRF. The attacker hosts a web page with a form that appears legitimate. This page already contains the attacker's request. Here, the form does not belong to the website that is trying to access. The form will be his own, or it might belong. It might belongs to some other website also. That's why this form will be injected into the targeted website. So that's why it is called as cross-site request forgery attack. So now this malicious form, you can call it as a malicious form, you will send to the victim. The victim, believing the form to be the original, enters a login and password. Once the user completes the form, that page is submitted to the real site. So the real site's server accepts the form, assuming that it was sent by the user based on the authentication credentials. So this is how CSRF hijacks the session. Next is compromising session IDs using session replay attacks. The user establishes a connection with the web server. The server asks the user for authentication information as identity proof. User sends authentication tokens to the server. In this step, an attacker captures the authentication token of the user by eavesdropping on the conversation between the user and the server. Once the authentication token is captured, the attacker replays the request to the server with the captured authentication token and gains unauthorized access to the server. So here the attacker will use already sent token by a user again to the server. Already used one, it will send to the server again and gains the access. That's why it's called as replay attack. Is resending the token again to the server. Next, compromising session ID is using session fixation. In other attacks, we saw the attacker steals, guesses, brute forces the session IDs. But in this type of attack, the attacker issues a session ID to the user, to the user's browser, forcing it to use this session ID. Here, attacker fixes the user session ID in advance instead of generating it randomly at the time of login. So here attacker decides the session IDs and he will give the session ID to the user. The attacker takes advantages of limitations in web application session ID management. Web applications allow the user to authenticate themselves using an existing session ID instead of generating a new session ID. So this is obviously a bad idea. Here the server need not generate the session ID. Even the user also can generate the session ID. which was already given to the user by the server during some other sessions. So the attacker is using this vulnerability to fix a session ID. So there are different ways to perform this session fixation attack. He can uh, use this session token in the URL argument, the session token in a hidden form field, session ID in a cookie. So, so this in turn has three phases. This session fixation attack has three phases. Session setup phase. In this phase, attacker obtains a legitimate session ID by establishing a connection with the target web server. Few web servers supports the idle session timeout feature. If the target web server supports this feature, the attacker needs to send requests repeatedly to keep the established trap session alive. Fixation phase. In this phase, the target introduces the session ID to the victim's browser, thereby fixing the session. Entrance phase. In this phase, the attacker waits for the victim to log into the target web server using the trap session ID and then enters the victim's session. So, steps in detail. First, the attacker establishes a legitimate connection with the target web server. The target web server, say for example, citibank.com, issues a session ID, say 123, to the attacker. The attacker sends a link with the established session ID, say http citibank.com, say SID equal to 123, to the victim and lures the victim to click on it to access the website. The victim clicks on the link, believing it to be a legitimate link sent by the bank. This opens the server's login page in the victim's browser for the SID 123. So the web server checks that the session ID 123 is already established and is in an active state. Hence, it does not create a new session. Finally, the victim enters their login credentials in the login script and the server grants them access to the bank account. At this point, the attacker already knows the session ID because he has given the session ID to the victim. So, and using this session ID, he can access the victim's bank account via example http citibank.com SID equal to 123. Next, so after compromising session ID is using session fixation. Let's see session hijacking using proxy servers. Here, the attacker lures the victim to click on a fake link which appears legitimate but redirects the user to the attacker server. The attacker then forwards the request to the legitimate server on behalf of the victim and serves as a proxy for the entire transaction. Acting as a proxy, the attacker captures the session information during the interaction between the legitimate server and user. So as you can see in the figure, first an attacker sends some link. Here in this example is the link name is click here for a 50% discount at amazon.com. But actually the link, if you look at the link URL, it is to the website, malicious website, which the attacker wants the victim to visit. The victim seeing only the name of the link, you will click on the link and you will go to the attacker server. So here from the attacker server, the request will be sent to the amazon.com server. So then now the attacker server will act as a proxy between the victim and the legitimate server, that is amazon.com. So he can um, he can actually see the data that is transferred between the victim and the amazon.com, the legitimate server.